Look up at the night sky on a clear evening. You see the moon, a few bright planets, a sprinkle of stars. It all seems so serene, so orderly, almost predictable. We learn the names of the planets as children, draw the solar system in school, and come to think of our cosmic neighborhood as a familiar, well-mapped place. But what if everything we thought we knew was wrong? What if this seemingly tranquil system is actually a cosmic stage for the utterly bizarre, a collection of worlds more strange and wondrous than our wildest science fiction? It turns out the truth is far more compelling than the simple model we were taught. Beyond the placid orbits and textbook diagrams lies a reality filled with unexplained phenomena, geological oddities that defy logic, and mysteries that have left even the most seasoned astronomers utterly baffled. Our solar system is not a museum of dead rocks and quiet giants. It is a living, breathing, and deeply weird collection of worlds, each with its own secrets waiting to be uncovered. This journey of discovery is what we're embarking on today. We're going to venture far beyond the basic facts and dive headfirst into the anomalies, the head-scratchers, the discoveries that truly challenge our understanding of physics, geology, and even the potential for life. From a world that rains molten glass to a moon hiding a vast subsurface ocean, from magnetic fields that shouldn't exist to hexagonal storms larger than our entire planet, the solar system is a treasure trove of the inexplicable. These aren't just minor curiosities, they are fundamental puzzles that force us to rewrite the rules, to question our assumptions, and to look at our place in the cosmos with a renewed sense of awe and humility. Every bizarre finding is a reminder that we are still just beginning to comprehend the true nature of the universe we call home. In this video, we will count down 25 of the most bizarre discoveries ever made right here in our own solar system. This isn't a dry lecture, it's an expedition. We'll explore volcanic plumes on a distant moon, uncover the mystery of a world that's darker than coal, and investigate the strange, rhythmic signals that echo from the depths of space. Each entry on our list is a story in itself, a testament to human curiosity and the powerful tools we've built to peer into the cosmic dark. So get comfortable and prepare to have your perspective shifted. The solar system you're about to discover is stranger, more dynamic, and infinitely more fascinating than you ever imagined. And so we begin our countdown not with a distant, flickering star, but with a feature so geometrically perfect and so unnervingly stable that it seems to defy the very nature of chaotic weather. At number 25, we have the Great Hexagon of Saturn. Nestled at the gas giant's north pole is a colossal, six-sided jet stream, a swirling polygon of clouds and wind that has endured for decades and possibly even centuries. This isn't a trick of shadow or light. It's a real, persistent atmospheric structure, a hurricane-like storm with sides each longer than the diameter of our entire planet. To put its scale into perspective, if you could somehow place Earth next to this hexagon, our entire world would fit neatly inside its borders with room to spare. When the Cassini spacecraft first returned clear images of this phenomenon, scientists were, to put it mildly, stunned. Weather patterns on Earth are turbulent and transient, forming messy spirals and irregular shapes that dissolve almost as quickly as they appear. But Saturn's hexagon is a monument of order. Its sides are razor-sharp, its vertices precisely 60 degrees apart, and it rotates in a tight, stable lock with the planet's rotation itself. It looks less like a natural weather formation and more like a piece of cosmic engineering, a glyph carved into the atmosphere of a giant. So, how does such a perfect shape form in the churning hydrogen-helium soup of a gas giant's atmosphere? The leading theory points to the complex dance of atmospheric dynamics. Imagine a fluid, in this case the gases of Saturn's upper atmosphere, moving at different speeds. If you have a jet stream, a fast-flowing, narrow air current, and beneath it, deeper layers of the atmosphere are rotating at different velocities, this can create a phenomenon known as a standing wave. It's somewhat similar to the way a vibrating guitar string creates a stable, oscillating pattern. In Saturn's case, the conditions at the precise latitude of the North Pole seem to be just right to generate a standing wave with 6 peaks and 6 troughs, which then gets etched into the clouds, tracing out this colossal hexagon for all to see. Other theories have explored the role of giant, rotating vortices that could pinch the jet stream into this shape, but the standing wave model remains the most robust explanation we have. What remains utterly baffling is its longevity. Storms on Earth last for days or weeks. This hexagonal storm has been observed for over 40 years and shows no sign of weakening. It is a permanent, swirling puzzle at the top of our solar system's most spectacular ringed world. A stark reminder that the laws of physics can create patterns of beauty and order that, from our earthly perspective, seem almost impossible. Leaving behind the geometric perfection of Saturn's hexagon, we descend through the thick, orange haze of its largest moon, arriving at a landscape that is at once hauntingly familiar and profoundly alien. At number 24, we encounter the methane lakes of Titan. This isn't a world of rock and dust. It's a world of fluid, with great seas and sprawling lakes dotting its surface, making Titan the only other place in our entire solar system, besides Earth, known to have stable bodies of liquid on its surface. But you wouldn't want to go for a swim here. Instead of water, these lakes and seas are filled with a frigid, swirling mix of liquid methane and ethane, hydrocarbons that exist as gases here on Earth but on the super-cold surface of Titan, with temperatures plummeting to -290 degrees Fahrenheit. They flow as liquids, carving river valleys and pooling into vast basins. When the Cassini spacecraft arrived at Saturn, it carried a special passenger, the Huygens probe, which was destined for Titan. As Huygens parachuted through the Moon's dense, nitrogen-rich atmosphere, it sent back images of a pale, rocky landscape with what appeared to be drainage channels, evidence of flowing liquid in the not-too-distant past. But the true revelation came from Cassini's radar, which could pierce the opaque, orange smog. The radar maps it returned were nothing short of breathtaking. They revealed a complex hydrologic system, a mirror of Earth's own water cycle, but operating with a completely different chemistry. There are large, smooth areas identified as immense seas like Kraken Mare, which is larger than North America's Lake Superior. There are also countless smaller, dark patches that are lakes, often with incredibly smooth, radar-dark surfaces indicating they are filled with liquid. Some of these lakes are perched in highland areas, connected by what look like river channels, while others are gathered in great, low-lying basins, forming an alien coastline under a dim, orange sky. This existence of an active liquid cycle opens up one of the most fascinating possibilities in all of astrobiology. Life as we know it requires liquid water as a solvent, a medium in which chemical reactions can take place. Titan presents a radical alternative. Could a different kind of life, a life not as we know it, use liquid methane as its solvent? The basic ingredients for life, often referred to as probiotic chemistry, are abundant on Titan. Its atmosphere is a thick soup of nitrogen and methane, bombarded by solar ultraviolet radiation that breaks these molecules apart, allowing them to reform into more complex organic compounds. These compounds, including amino acids and nucleotides, rain down onto the surface, potentially collecting in those methane lakes and seas. It's conceivable that in the depths of these dark, cold bodies of liquid hydrocarbon, a truly alien biochemistry could have arisen, one that breathes hydrogen instead of oxygen and uses methane the way we use water. While this remains entirely hypothetical, it transforms Titan from a mere geological curiosity into a prime candidate in the search for life, a world that challenges our very definition of what life is and where it can exist. This makes Titan not just a bizarre world, but a profoundly important one, a natural laboratory showing us that the processes that can lead to life might be far more versatile and wondrous than we ever dared to dream. Now, let's turn our attention from the sprawling hydrocarbon lakes of Titan to a much smaller, but arguably even more active moon of Saturn, a world that has completely rewritten our understanding of where life could potentially exist. At number 23, we have the spectacular icy plumes of Enceladus. For decades, Enceladus was considered just another frozen, dead ball of ice, a mere 500 kilometers across, so small that most scientists assumed its geological activity had ceased eons ago. But in 2005, the Cassini spacecraft revealed something that sent shockwaves through the scientific community. It discovered enormous geysers, colossal plumes of water vapor and ice crystals, violently erupting into space from a series of massive fractures near the moon's south pole. These weren't just minor outgassing events. They were jets shooting hundreds of kilometers above the surface, creating a gigantic plume so vast that it actively feeds one of Saturn's outer rings, the E-ring, with fresh ice particles. Here was a tiny, unassuming moon, actively spewing its own internal contents out into the solar system. The immediate and profound implication of these plumes was the confirmation of a vast global subsurface ocean. The only way such powerful, continuous eruptions could occur is if there was an immense reservoir of liquid water beneath the icy crust, kept warm and liquid by the gravitational tug of war between Enceladus and Saturn. This process, known as tidal heating, flexes the moon's interior, generating enough energy to prevent the ocean from freezing solid. The tiger stripe fractures, those four prominent parallel cracks at the South Pole from which the plumes erupt, act like nozzles. As the icy crust is pulled and stretched by Saturn's gravity, these fractures open and close, allowing the pressurized water from the ocean below to explosively decompress and flash freeze into a magnificent spray of ice and vapor. It's a cryovolcanic phenomenon, a cold volcano of water instead of molten rock, and it presented an unprecedented opportunity. We didn't need to land a spacecraft and drill through miles of ice. Enceladus was offering us a free sample of its hidden ocean, shooting it directly into space for us to catch. And catch it we did, in a series of some of the most daring maneuvers ever performed by an interplanetary probe. The Cassini spacecraft repeatedly and courageously flew directly through these towering plumes. Skimming just tens of kilometers above the moon's stark, icy surface, Cassini's instruments sampled the composition of the spray. What they found was nothing short of revolutionary. The plumes were not just pure water, they contained a fascinating cocktail of ingredients essential for life. They found simple organic compounds like methane and propane, but more critically, they detected complex carbon-rich macromolecules. Even more stunning was the discovery of molecular hydrogen and tiny particles of silica nanograins. The presence of molecular hydrogen is a particularly powerful piece of evidence, as it strongly suggests that hydrothermal vents are active on the seafloor of Enceladus's ocean. On Earth, such vents on the deep ocean floor, where superheated, mineral-rich water spews from the crust, are teeming with life. The chemical energy provided by hydrogen is a primary food source for entire ecosystems of microbes that, in turn, support larger organisms like tube worms and clams, all thriving in total darkness. The chemistry Cassini detected points to this exact same kind of process happening right now, today, on the seafloor of an alien ocean. This transforms Enceladus from a curious moon into arguably the single most promising place to search for life beyond Earth. It has all three of the fundamental requirements for life as we know it: a vast, long-lived source of liquid water, a rich soup of organic compounds containing carbon, and a readily available source of chemical energy from hydrothermal activity. Its ocean is likely in direct contact with a rocky core, allowing for the mineral exchanges that life-sustaining chemistry requires. We are no longer just looking for potentially habitable environments from the distant past like on Mars. we are looking at a world that is demonstrably habitable in the present day, a world that is actively broadcasting its life-giving potential across the solar system. The plumes of Enceladus are a cosmic invitation, a beacon pointing us toward a dark, watery abyss that may very well be home to the first extraterrestrial life forms we ever discover. Shifting our gaze from the active plumes of Enceladus, we find another frozen world hiding a secret ocean, but one that presents its mysteries in a completely different and visually stunning way. At number 22, we explore the chaotic terrain of Jupiter's moon Europa. Seen from a distance, Europa is a gleaming, white orb streaked with an intricate web of reddish-brown lines, resembling a cosmic marble or a cracked eggshell. These bizarre features crisscross the entire surface, a testament to a world that is far from geologically dead. Unlike Enceladus, which actively sprays its internal ocean into space, Europa keeps its secrets locked beneath a thick, global shell of ice, but the surface tells a dramatic story of the forces churning below. The most compelling theory to explain this fractured landscape is the presence of a massive global ocean, containing more than twice the volume of all Earth's oceans combined, hidden beneath an icy crust that may be tens of kilometers thick. This isn't a stagnant, frozen block. The surface we see is a dynamic puzzle of ice rafts, jumbled terrain, and those mysterious linear streaks officially called lineae. Scientists believe these reddish-brown lines are fractures in the ice shell, where relatively fresh and pure ice from below has welled up to the surface. The distinctive color is likely caused by salts and organic compounds material that has been churned up from the ocean beneath, possibly altered by radiation from Jupiter's powerful magnetic field. The sheer scale of this activity is breathtaking. Vast sections of the icy crust appear to have broken apart, drifted, and then refrozen into new, chaotic configurations, like pack ice on Earth but on a planetary scale. This constant resurfacing means Europa has one of the youngest surfaces in the solar system, with very few impact craters, indicating that geological processes are continually erasing evidence of its past, creating a world that is perpetually renewing itself. What truly ignites the imagination, however, is what might be happening at the very bottom of this dark global sea. Just like with Enceladus, the primary suspect for keeping this immense body of water liquid is tidal heating. As Europa orbits Jupiter, the massive planet's gravitational pull flexes and squeezes the moon, generating immense internal heat through friction. This heat prevents the ocean from freezing solid and likely drives geological activity on the seafloor. The critical question is whether this seafloor features hydrothermal vents, geyser-like structures spewing mineral-rich, superheated water into the abyss. On Earth, such vents are vibrant oases of life, supporting entire ecosystems that thrive in total darkness, powered not by sunlight but by chemical energy. If similar vents exist on the seafloor of Europa, they could provide the perfect conditions for life to arise and persist: liquid water, a rich supply of energy, and the necessary minerals and chemistry for biological processes. The evidence we have, while indirect, is incredibly suggestive. The Hubble Space Telescope has even detected what appear to be transient water vapor plumes erupting from Europa's south polar region, faint echoes of the spectacular shows put on by Enceladus. While these plumes are much more sporadic and difficult to confirm, their potential existence offers another tantalizing hint that the ocean is interacting with the surface and may even be accessible for future study. Upcoming missions like NASA Europa Clipper are designed specifically to unravel these mysteries. This spacecraft will conduct dozens of close flybys, using powerful radar to peer through the icy shell and measure its thickness, while its sophisticated suite of instruments will analyze the composition of the surface and any potential plumes in exquisite detail. It will essentially taste the surface from orbit, searching for those telltale organic compounds and salts that would confirm the ocean's habitability. The chaotic, cracked surface of Europa is not just a geological curiosity. It is the visible signature of a hidden, watery world, a place that may hold the answers to one of humanity's oldest and most profound questions: are we alone in the universe? But for our next discovery, we leave behind the hidden oceans of icy moons and travel to a world that is the complete opposite, a place where the internal heat of a planet is not hidden away, but is violently and spectacularly on display for the entire universe to see. At number 21, we arrive at the volcanoes of Io, Jupiter's fiery inner moon. If you were to imagine hell as a physical place in our solar system, Io would be it. This is not a world of frozen stillness. It is the most volcanically active body we have ever encountered. A geological pressure cooker where the very surface is continuously being remade by eruptions of unimaginable ferocity. The first hints of Io's extraordinary nature came from the Voyager probes in the late 1970s. As Voyager 1 sped past, scientists were astonished to see a bizarre, mottled surface devoid of impact craters, painted in vibrant hues of yellow, orange, and red from various forms of sulfur. But the real shock came from navigation engineer Linda Morabito, who, while analyzing an image, noticed a strange, umbrella-shaped plume extending hundreds of kilometers off the moon's limb. This was not a cloud, it was the eruption of a volcano actively spewing material into the vacuum of space. Subsequent observations from Voyager and later the Galileo orbiter confirmed the staggering truth: Io is a world covered in volcanoes. We have now catalogued over 400 active volcanic centers, with major eruptions happening so frequently that the entire surface of the moon is resurfaced about every 1 million years. This explains its youthful, crater-free face. Impact scars are simply buried under a constant rain of fresh volcanic material. The driving force behind this inferno is not the radioactive decay of elements in its core, as is the primary heat source for Earth's volcanoes. Instead, Io is roasted from the inside out by the immense gravitational pull of Jupiter. Io orbits deep within Jupiter's powerful gravity well, and its path is tugged and squeezed by the neighboring moons Europa and Ganymede. This orbital dance creates a phenomenon known as tidal heating. As Io moves in its slightly elliptical orbit, Jupiter's gravity flexes the entire moon, stretching and compressing its interior by as much as 100 meters with each pass. This constant, rhythmic kneading generates colossal friction and heat within Io's rocky mantle, melting vast portions of it into a global ocean of magma. This subsurface sea of molten rock then forces its way to the surface through any available weakness, creating the most spectacular volcanic displays in the solar system. The eruptions themselves are of a scale that dwarfs anything on Earth. We see immense volcanic plumes, like the one first spotted by Voyager, that shoot fountains of sulfur and sulfur dioxide gas hundreds of kilometers high, so high that some of the material escapes Io's weak gravity entirely, feeding a giant, donut-shaped cloud of ions that encircles Jupiter itself. We see vast lava lakes larger than entire cities, with crusts that constantly break apart and reform in a churning, incandescent ballet. The lava that flows on Io is unimaginably hot. Recent studies suggest temperatures can exceed 1,600 degrees Fahrenheit, which is hundreds of degrees hotter than typical basalt lava on Earth. This indicates that the magma is likely composed of ultramafic silicates, a primitive, superheated rock that hasn't been common on our planet for billions of years. The most powerful individual volcano, known as Loki Patera, is a depression the size of Lake Ontario that behaves like a massive, overturning caldera. Its periodic brightenings make it the most consistently powerful volcanic hotspot in the entire solar system, releasing more continuous energy than all of Earth's volcanoes combined. The visual evidence sent back by our spacecraft paints a picture of an alien and terrifying beauty. The Galileo mission captured stunning images of glowing lava flows snaking across the dark landscape, and its infrared instruments mapped the intense heat radiating from countless volcanic vents. The New Horizons spacecraft, on its way to Pluto, even managed to catch a colossal eruption in progress, capturing a plume 290 kilometers high as it raced through the Jupiter system. Io stands as a permanent monument to the raw, untamed power of orbital mechanics. It is a world being turned inside out by the gravitational embrace of its colossal parent planet, a stark and vivid reminder that the forces shaping our solar system are not always gentle or subtle. Where Europa and Enceladus hide their energy beneath a shell of ice, Io screams it into the void, a brilliant and relentless fire in the dark. Now, let's journey from Jupiter's tumultuous moons inward toward the searing heat of the Sun, to a world that has long defied a fundamental expectation. At number 20, we investigate the magnetic mystery of Mercury. For years, scientists considered this small, scorched planet to be essentially a fossil world, a heavily cratered ball of rock that had cooled off completely billions of years ago. A key piece of evidence for this was the assumption that its core must have solidified long ago. On Earth, our global magnetic field is generated by a churning liquid iron core, a so-called dynamo effect. Since Mercury is so small, it should have lost its internal heat rapidly, and its core should have frozen solid, shutting down any planetary magnetism. So when the Mariner 10 spacecraft flew by in the 1970s and detected a definite, albeit weak, magnetic field, it sent planetary scientists right back to the drawing board. How could this tiny, seemingly dead world possibly still have an active magnetic dynamo? The answer, it turns out, may be one of the most bizarre geological concepts in the entire solar system, a phenomenon known as iron snow. Think about a snow globe, but instead of a quaint winter scene, imagine the entire core of a planet. The prevailing theory suggests that Mercury's core is not entirely solid, nor is it entirely liquid. It exists in a strange, transitional state. Deep within the planet, the immense pressure and specific composition of the core mean that the molten iron alloy is slowly cooling. As it cools, pure iron crystals begin to condense out of the liquid mixture, much like snowflakes forming in a cloud. But here's the twist that defies intuition. On Mercury, this metallic snow doesn't float upward, it falls. These crystals of solid iron are denser than the surrounding liquid, so they slowly sink inward, showering down toward the very center of the planet. This continuous snowfall of iron creates a colossal engine deep within Mercury. As the solid crystals descend, they displace the lighter liquid material, which is rich in elements like sulfur that lower its melting point. This displacement sets up a slow, global churning motion, a gentle convection within the liquid outer core. It is this movement of an electrically conductive fluid, in this case the molten iron alloy, that generates Mercury's magnetic field through the dynamo effect. It's a much weaker and more complex process than Earth's vigorous core convection, which explains why Mercury's magnetism is only about 1% the strength of our own. The Messenger spacecraft, which orbited Mercury from 2011 to 2015, provided critical data that strongly supports this iron snow theory. Its detailed measurements of the planet's gravity field and the precise characteristics of its magnetism were consistent with a core that is still partially molten and chemically stratified, exactly the kind of environment where this exotic snowfall could occur. This isn't just a dead rock after all, it's a world with a slowly churning, crystallizing heart, a place where the most fundamental processes of planetary cooling are playing out in a way we never anticipated. As we venture outward again, back to the realm of Saturn's moons, we encounter a world that presents one of the most visually striking and immediately obvious mysteries in the solar system. At number 19, we meet Iapetus, the two-faced moon. When the Cassini spacecraft first captured detailed images of this distant satellite, scientists could hardly believe what they were seeing. One entire hemisphere of Iapetus is as bright and reflective as freshly fallen snow, a brilliant, icy landscape. The other hemisphere, however, is coated in a material as dark as charcoal or black velvet, creating a contrast so severe it looks as if two completely different worlds have been clumsily glued together. This isn't a subtle gradient, it's a razor-sharp divide between day and night, a yin-yang symbol rendered on a planetary scale. The leading explanation for this bizarre appearance involves an interplanetary dust-up with a celestial neighbor. The theory points the finger at Phoebe, a small, dark, and irregularly shaped moon orbiting Saturn far beyond Iapetus in a retrograde or backward direction. Phoebe is constantly being bombarded by tiny micrometeoroids, which kick up a fine, dark dust from its surface. Because Phoebe orbits in the opposite direction to Iapetus and most of Saturn's other major moons, this dust doesn't just drift aimlessly. It gets swept inward, spiraling slowly towards Saturn like cars driving the wrong way on a cosmic freeway. Iapetus, with its stately, prograde orbit, plows directly through this stream of infalling debris. Think of it as a giant, icy windshield on a dusty road. The leading hemisphere of Iapetus, the face that is always forward in its orbit, gets continuously coated with this dark material. This explains why one side is almost uniformly black, while the trailing hemisphere, protected from this cosmic sandblasting, remains pristine and bright. But the mystery deepens with a powerful thermal feedback loop that amplifies this initial dusting. The dark material on the leading hemisphere isn't just a passive coating, it fundamentally changes the moon's thermal properties. Dark surfaces absorb more sunlight and heat up significantly more than bright, reflective icy surfaces. As the dark areas on Iapetus warm up, any exposed water ice adjacent to them sublimates. That is, it turns directly from a solid into a gas without ever becoming a liquid. This water vapor then travels across the moon's surface, eventually reaching the colder, brighter areas and the frigid poles, where it recondenses as a fresh, bright layer of frost. This process creates a self-reinforcing cycle. The dark areas get darker as they lose their bright ice, which then gets deposited on the bright areas, making them even brighter. Over millions of years, this thermal segregation has sharpened the contrast to an extreme degree, creating the almost unnatural-looking boundary we observe today. It's a powerful demonstration of a runaway process where a small initial difference, amplified by feedback, can lead to a dramatically bifurcated world. The visual evidence from Cassini is nothing short of stunning. Side-by-side images show a world cleaved in two. The dark region, named Cassini Regio after the moon's discoverer, has an albedo or reflectivity of only about 4 or 5%, similar to fresh asphalt. The bright, icy terrain, on the other hand, reflects over 60% of the sunlight that hits it. Adding to the moon's peculiar character is its prominent equatorial ridge, a chain of mountains that runs perfectly along its equator, making it look remarkably like a cosmic walnut. While the ridge is a separate geological mystery, its presence on this already bizarre world only adds to the enigma. Iapetus stands as a stark monument to the power of simple physical processes, collisional dust and basic thermodynamics, to create some of the most visually arresting and seemingly artificial-looking landscapes in our cosmic neighborhood. It is a perfect, natural example of how a single world can embody two radically different identities. Yet for a truly sobering example of how planetary climates can be pushed to the extreme, we need to travel inward to our very own twin. At number 18, we confront the runaway greenhouse of Venus. In many ways, Venus is Earth's almost perfect sibling, a world of nearly identical size, mass, and composition, formed from the same primordial cloud of dust and gas. You might expect it to be a slightly warmer version of our own world, perhaps dotted with tropical oceans. The reality, however, is a stark and terrifying departure. Venus is a blistering, suffocating hellscape, a permanent monument to what can happen when a planet's climate system spirals completely out of control. Its surface temperatures soar to a staggering 880 degrees Fahrenheit, which is hot enough to melt lead and even zinc. The atmospheric pressure at the surface is a crushing 90 times that of Earth, equivalent to the pressure you would feel nearly a kilometer beneath our ocean waves. This is not the gentle, cloud-shrouded morning star of poetry. This is a planetary furnace. The engine of this inferno is its atmosphere, an overwhelmingly dense shroud of carbon dioxide. While Earth's atmosphere is mostly nitrogen with only a trace of carbon dioxide, Venus's air is 96% carbon dioxide. This has triggered a runaway greenhouse effect of almost unimaginable intensity. Here's how it works. Sunlight penetrates the atmosphere and warms the surface. The surface then tries to cool down by radiating heat back outward as infrared radiation. But on Venus, that thick blanket of carbon dioxide is almost perfectly designed to trap this outgoing heat. The gas absorbs the infrared radiation, re-emitting much of it back toward the surface, preventing the planet from cooling down. This creates a vicious, self-perpetuating cycle. As the surface gets hotter, any carbon that was locked away in rocks, in carbonates for instance, is baked out and released into the atmosphere as even more carbon dioxide, which in turn traps even more heat. Scientists believe that in the distant past, Venus may have even had shallow oceans, but as the sun grew brighter, the planet warmed, the oceans began to evaporate, and water vapor, itself a potent greenhouse gas, accelerated the heating until a tipping point was crossed. The oceans boiled away entirely, and all the water vapor was eventually broken apart by sunlight, with the lightweight hydrogen escaping to space and the oxygen bonding with other elements. The planet was left with the desiccated carbon dioxide-dominated atmosphere we see today, a permanent and oppressive thermal trap. The bizarre consequences of this extreme environment don't stop at the scorching temperatures and crushing pressure. High in the Venusian atmosphere, on its tallest mountain ranges like Maxwell Montes, radar data from old Soviet Venera missions and more recent orbital observations suggest a truly strange form of precipitation. It appears to snow, but not with water ice. The metallic elements in the volcanic gases, such as lead sulfide and bismuth sulfide, vaporize in the intense heat at lower altitudes and rise into the cooler upper atmosphere. There, they condense directly into shiny, metallic particles that fall toward the surface. This isn't the gentle, flaky snow of Earth. It's a mist of glittering metal that likely coats the mountain peaks before sublimating back into vapor on the long, hot slide down the slopes. It's a landscape where the very mountains could be dusted with a frost of fool's gold and other metallic compounds, a phenomenon as beautiful as it is alien. Adding to its list of oddities, Venus also rotates in the opposite direction to almost every other planet in the solar system, a motion known as retrograde rotation. From a point high above the Sun's north pole, you would see all the planets spinning counterclockwise on their axes and orbiting in the same direction. Except for Venus, it spins clockwise very slowly. A single day on Venus, the time it takes to complete one full rotation, is actually longer than its year. It takes 243 Earth days to spin once, but only 225 Earth days to complete one orbit around the Sun. The leading theory for this backward spin is a colossal impact in the solar system's early history, a titanic collision with another protoplanet that literally knocked Venus upside down, setting it spinning the wrong way. This unique rotation creates a surreal rhythm on the surface, where the Sun would rise in the west and set in the east, but it would do so only once every 117 Earth days as the slow rotation and the orbital motion combine. Venus, therefore, stands as a profound and cautionary twin. It shows us that a world born with all the same advantages as Earth can be utterly transformed by the delicate balance or catastrophic imbalance of its atmosphere. It is a permanent reminder of the awesome power of the greenhouse effect and a sobering lesson in planetary climate stability. Yet even the two-faced starkness of Iapetus seems almost orderly when compared to the cosmic pandemonium we find at number 17, the chaotic spin of Hyperion. This moon of Saturn is unlike any other you have ever seen. It doesn't look like a world at all, but rather like a gigantic celestial sponge or a porous, grayish potato that has been violently pummeled by cosmic impact. Its surface is a bizarre, fractal landscape of deep, dark craters with sharp, jagged rims, giving it an incredibly low density that suggests it is mostly empty space, a rubble pile held together by the faintest of gravitational grips. But the true strangeness of Hyperion isn't just its appearance, it's how it moves. This is the only known moon in our solar system that rotates chaotically. It does not spin on a fixed axis like a top. Instead, it tumbles through its orbit in an utterly unpredictable and random fashion, a dizzying celestial acrobat with no sense of direction. The reason for this bizarre behavior lies in a perfect storm of orbital circumstances. First, its highly irregular, potato-like shape means its gravitational field is uneven and lumpy. It doesn't have the symmetrical gravitational pull of a sphere, so as it moves, the relentless tidal forces from its massive parent planet, Saturn, tug on it erratically. Second, and most critically, Hyperion is locked in a gravitational resonance with its larger, spherical neighbor, Titan. For every 3 times Titan orbits Saturn, Hyperion orbits almost exactly 4 times. This precise rhythm might seem like it would create stability, but for an object with Hyperion's weird shape, it has the opposite effect. The periodic gravitational kicks from Titan, combined with Saturn's own tidal pulls, act like a series of random pushes on an already wobbly object. Its rotation becomes chaotic in the strict mathematical sense, meaning its motion is fundamentally unpredictable over long timescales. A small, tiny difference in its starting position or velocity would lead to a completely different rotational state just a few weeks later. It is a real-world demonstration of chaos theory, a celestial example of the so-called butterfly effect. Imagine trying to predict the path of a single leaf tumbling down a rocky stream, buffeted by eddies and currents from all sides. That is the motion of Hyperion. Its rotational axis wobbles so dramatically that there is no consistent north or south pole. If you were standing on its surface, a dangerous prospect given its weak gravity, the sun would not rise and set in a reliable pattern. One day, the sun might arc across the sky. The next, it might loop erratically, dip below the horizon, then pop back up again. Or it might vanish for long, unpredictable periods of darkness before reappearing in a completely different part of the sky. There is no day-night cycle as we understand it, only a perpetual, chaotic light show. The visual evidence from the Cassini spacecraft, which flew close by in 2005, is jaw-dropping. The images reveal a world that looks like it's made of foam, with deep, dark pits that seem to swallow light, creating an incredibly rough and porous texture unlike any other solid body we've encountered. This tumbling motion has prevented Hyperion from settling into a stable rotation for billions of years, making it a permanent celestial rebel, a world that defiantly refuses to follow the orderly rotational rules obeyed by every other substantial moon in our solar system. Leaving behind the chaotic tumbling of Hyperion, we venture to the frozen frontier of our solar system, to a world that is both an captured alien and a surprisingly active member of Neptune's family. At number 16, we find the cantaloupe terrain of Triton. When the Voyager 2 spacecraft flew past Neptune in 1989, it revealed a moon that defied all expectations. Triton is a world of stunning contradictions, and its most immediately bizarre feature is its skin. Vast regions of its surface are covered in a landscape that looks uncannily like the rind of a cantaloupe melon, a vast, intricate pattern of dimples and interconnected ridges, a geological texture never seen anywhere else. These features, now officially known as cantaloupe terrain, are believed to be diapirs, vast blobs of less dense, icy material that have slowly pushed their way up from the subsurface, deforming the overlying crust over millions of years. It's as if the moon's icy skin is slowly bubbling from within, frozen in a state of perpetual, sluggish upheaval. This strange surface is just the beginning of Triton's mysteries. Its very existence around Neptune is a clue to a violent past. Triton orbits Neptune in a retrograde direction, meaning it moves backwards relative to the planet's rotation. This is a major red flag in planetary science. Moons that form alongside their planet from a disk of gas and dust all orbit in the same prograde direction, just like the planets around the Sun. A large moon in a retrograde orbit is a clear sign of a capture event. Triton was almost certainly not born here. Billions of years ago, it was a free-flying dwarf planet in the Kuiper Belt, the ring of icy bodies beyond Neptune. Through some gravitational interaction, perhaps a close encounter with Neptune that robbed it of energy, or a complex dance involving a binary partner that was ejected, Triton was snared by the ice giant's gravity and forced into its peculiar orbit. This capture would have been incredibly violent, unleashing immense tidal forces that melted Triton's interior completely, creating a subsurface ocean that has only slowly refrozen over the eons. This explains why its surface is so young and devoid of large craters. That ancient captured surface was completely resurfaced by the heat of its own traumatic birth. But the most breathtaking discovery from Voyager's brief flyby was the evidence that Triton is not a dead, frozen relic. It is geologically active today. The spacecraft's cameras captured dark, towering plumes reaching up to 8 kilometers high, stark against the bright, icy backdrop. These are geysers, not of water, but of nitrogen gas mixed with dark dust. The mechanism is as ingenious as it is alien. Triton's surface is covered in a thin layer of nitrogen ice. As it moves in its elliptical orbit, its seasons change, and the weak sunlight can penetrate this translucent ice, warming a dark, dusty layer just beneath the surface. This trapped heat vaporizes the solid nitrogen ice underneath, building up tremendous pressure until it finally erupts, punching through the icy crust and carrying the dark dust high into the tenuous atmosphere. The plumes then drift for miles in Triton's thin winds, creating long, dark streaks across the landscape. This makes Triton one of the very few worlds in the outer solar system, alongside Enceladus and Io, where we have direct visual proof of current geological activity. The combination of its captured nature and its ongoing eruptions makes Triton a singular object of fascination. It is a Kuiper Belt object that we can study up close, a fossil from the solar system's earliest days that is conveniently parked in our own planetary backyard. Its cantaloupe terrain speaks to a complex and active internal history. Its geysers reveal a world where even the faintest sunlight can drive dramatic change, and its backward orbit tells a story of cosmic theft on an epic scale. This frozen, active, captured world gives us a precious glimpse into the composition and behavior of the distant, primordial objects that still orbit in the deep freeze beyond Neptune. It's a reminder that even in the coldest, darkest reaches of our solar system, the fires of geology and the dynamics of orbital mechanics continue to shape strange and wonderful new worlds. From the captured chaos of Triton, we turn our attention to our other planetary neighbor, a world that has long fascinated humanity with its potential for life, yet possesses an atmosphere capable of unleashing a special kind of hell. At number 15, we confront the global dust storms of Mars. While Earth experiences hurricanes and monsoons, Mars produces a weather phenomenon of an entirely different magnitude. Colossal dust storms that can grow from a local disturbance to envelop the entire planet in a thick, choking haze, completely obscuring its surface features for weeks or even months at a time. Imagine a storm that doesn't just cover a continent but an entire world, turning the sky a murky, featureless pink and plunging the landscape into a perpetual, dusty twilight. The mechanics of how these planet-encircling monsters begin and grow are a fascinating blend of the familiar and the alien. It often starts with a relatively small, local dust devil or a wind gust kicking up fine particles in a region like the Hellas Basin, one of the largest impact craters in the solar system. On Mars, the atmosphere is incredibly thin, about 1% the density of Earth's, but it can still generate winds fast enough to lift dust. Here's where the feedback loop kicks in. The dust particles themselves are the key ingredient. As the sun heats the Martian surface, it warms the air closest to the ground. This warm air rises, carrying dust grains with it. Now, these suspended dust particles absorb solar radiation and heat the surrounding atmosphere. This localized heating alters air pressure gradients, which in turn strengthens the winds, lifting even more dust high into the sky. It's a self-fueling engine. The storm essentially creates its own weather system, growing and spreading like a cosmic wildfire across the face of the planet. The visual evidence of this process from orbit is both breathtaking and terrifying. Orbiters like NASA's Mars Reconnaissance Orbiter have captured stunning time-lapse sequences that show these storms in action. You can watch a small, localized dust cloud quickly expand, its tan-colored tendrils snaking across vast canyons and over towering volcanoes. Within days, multiple storm systems can merge, their leading edges forming a massive, advancing wall of dust that eventually wraps around the entire globe. The surface, once crisp with the details of craters, dunes, and polar ice caps, simply vanishes, replaced by a bland, opaque ball. From the surface, the experience is even more dramatic. The Opportunity rover, for instance, witnessed the sky darken as the dust blotted out the sun, turning daytime into an eerie, perpetual dusk. The Curiosity rover, with its nuclear power source, has weathered these storms by studying them from within, measuring the drop in air pressure and the accumulation of dust in the atmosphere. This is where the existential threat of these global storms becomes starkly real for our robotic explorers. For a solar-powered rover like the legendary Opportunity, a global dust storm is a life or death event. As the dust thickens in the atmosphere, it blocks the sunlight needed to charge the rover's batteries. At the same time, dust settles on the solar panels themselves, further reducing their efficiency. The rover is forced into a critical low-power mode, shutting down all but its most essential systems and waiting in a silent, frozen slumber for the storm to pass and the skies to clear enough for its batteries to recharge. Tragically, in 2018, a particularly intense and long-lasting global storm proved too much for Opportunity. The sky remained opaque for so long that the rover's internal systems, deprived of power, eventually grew too cold to operate, leading to the end of its historic mission. These storms are a powerful reminder of the harsh and unpredictable nature of the Martian environment. A world that can, without warning, shroud itself in a dusty veil and silence our mechanical emissaries on its surface. They represent a dynamic and violent aspect of a planet we often think of as a quiet, dusty desert, proving that Mars is still a world with a very active and formidable atmospheric personality. As we journey outward from the storms of Mars and the captured chaos of Triton, we arrive at a true oddball in our planetary family, a world that seems to defy every convention of planetary physics. At number 14, we encounter the weird and lopsided magnetosphere of Uranus. When we picture a planet's magnetic field, we often imagine a tidy set of lines arcing from one pole to the other, much like the symmetrical field generated by a simple bar magnet at a planet's core. But Uranus plays by a completely different set of rules. The Voyager 2 spacecraft, during its fleeting flyby in 1986, revealed a magnetic field that is profoundly askew, a discovery that left scientists both baffled and fascinated. The first major peculiarity is its extreme tilt. While Earth's magnetic North Pole is offset from its geographic North Pole by a modest 11 degrees, the magnetic field of Uranus is tilted a staggering 59 degrees from its axis of rotation. This means the planet's magnetic poles are located much closer to its equator than to its actual poles. To visualize this, imagine if Earth's magnetic north was suddenly relocated to somewhere near the latitude of Chicago. Compasses would spin wildly, pointing not toward the Arctic, but toward a spot in the middle of North America. The second major oddity is that this entire tilted magnetic field is not even centered on the planet's core. It is significantly offset, as if the magnetic engine inside Uranus is located off to one side. This combination of a severe tilt and a major offset creates a magnetosphere, the protective bubble of magnetic influence, that is inherently lopsided and asymmetric. As Uranus rotates on its side, its magnetic field tumbles through space in a corkscrew-like motion, creating a complex and ever-changing barrier against the solar wind. So, what could possibly generate such a bizarre magnetic configuration? The leading theory points to the planet's internal structure, which is radically different from the Earth's. Scientists believe that deep within Uranus, the immense pressures create a peculiar, slushy layer. This isn't a familiar liquid like water or molten rock, but a super-pressurized ocean of water mixed with dissolved ammonia and other ions, making it an excellent electrical conductor. It's in this relatively shallow, sloshing layer that the dynamo is thought to reside. Unlike Earth, where the magnetic field is generated by the convection of molten iron in the outer core, Uranus's field appears to be produced in this exotic water ammonia ocean. Because this layer is not deep within the center of the planet and is likely churning in complex, constrained patterns, it can generate a magnetic field that is both tilted and displaced. It's a bit like the difference between a perfectly centered spinning top and a wobbly top that's been bumped off center. The internal dynamics of Uranus create a magnetic wobble of cosmic proportions. This lopsided magnetosphere interacts with the solar wind, the constant stream of charged particles flowing from the Sun, in utterly unique ways. Animated models based on Voyager data show a magnetosphere that is highly asymmetric. On the side facing the solar wind, the magnetic field lines are compressed into a tight, irregular shield. On the side trailing away from the Sun, the field is stretched out into a long, twisted magnetic tail, like a cosmic windsock flapping in a stellar breeze. Because of the planet's extreme axial tilt, where its rotation axis is almost parallel to the plane of its orbit, this entire chaotic magnetosphere gets presented to the solar wind in a different orientation during each season of its 84 Earth-year orbit. At certain times, the magnetic poles are pointed almost directly at the Sun, a configuration unheard of for the other planets. This allows the solar wind to funnel charged particles directly down the magnetic field lines and into the upper atmosphere, potentially creating highly unusual and complex auroras that would dance not just around the poles, but across vast swaths of the planet. The magnetosphere of Uranus is therefore not just a scientific curiosity. It is a natural laboratory for studying magnetic dynamos under conditions we cannot replicate on Earth, showing us that the fundamental forces that shape our solar system can produce outcomes far stranger and more wonderful than our standard models could ever predict. Moving from the lopsided magnetic field of Uranus, we find another magnetic marvel much closer to home, a world whose hidden depths were revealed not by its surface, but by the invisible forces surrounding it. At number 13, we dive into the secret ocean of Ganymede. This isn't just any moon, it is the king of moons, the largest satellite in our entire solar system, a colossal world even bigger than the planet Mercury. For a long time, astronomers saw it as a fascinating but likely frozen ball of rock and ice, its surface a complex tapestry of ancient, dark, heavily cratered terrain and younger, lighter, grooved regions. But beneath that icy facade, a discovery of monumental importance was waiting, one that would transform Ganymede from a static giant into a dynamic world with a potentially habitable heart. The crucial clue came from an unexpected source, Ganymede's very own magnetic field. It is the only moon in the solar system known to generate its own intrinsic magnetic field, much like a planet. This was a massive surprise, as moons generally aren't large enough or possess the right internal conditions to power such a dynamo. As the Galileo spacecraft meticulously studied the Jupiter system throughout the late 1990s and early 2000s, it detected this small, internally generated field. But the real puzzle emerged when scientists observed how this field interacted with Jupiter's own vastly more powerful magnetic field. Jupiter's magnetic environment is a maelstrom of charged particles, and as Ganymede orbits within it, the data showed a second, independent magnetic field being induced, a kind of magnetic echo. This secondary field could only be explained if a large, global layer of an electrically conductive fluid existed within the Moon, sloshing in response to Jupiter's overpowering influence. That conductive fluid, according to sophisticated models, could only be one thing: a vast, salty subsurface ocean. The salt content is critical, as pure water is a poor conductor of electricity. But an ocean laden with salts, similar to Earth's oceans, would be conductive enough to generate the observed induced magnetic signature. Further evidence from the Hubble Space Telescope sealed the deal. By observing Ganymede's auroras, the faint, ultraviolet glowing ovals around its poles caused by Jupiter's magnetic particles, scientists noticed that these auroras didn't rock back and forth as much as they should have if the Moon were completely solid. The only explanation was that a global ocean beneath the crust was counteracting Jupiter's tidal pull, effectively suppressing the rocking motion of the auroras. The combined data painted an inescapable picture. Ganymede harbors a colossal ocean sandwiched between layers of ice, or between ice and a rocky seafloor, a hidden sea containing more water than all of Earth's oceans combined. This revelation immediately rockets Ganymede to the forefront of astrobiological interest. The standard recipe for life as we know it requires liquid water, a source of energy, and the necessary chemical building blocks. Ganymede's ocean provides the first ingredient on a staggering scale. The second ingredient, energy, is likely supplied by the same process that keeps the ocean liquid, tidal heating. Just as with Io and Europa, the gravitational tug of war from Jupiter and its sister moons flex Ganymede's interior, generating heat that prevents this immense water reservoir from freezing solid. The third ingredient, the right chemistry, is where things get particularly fascinating. The seafloor of this alien ocean is not just more ice. Scientists believe it is in direct contact with a rocky mantle. This is a crucial distinction. That rock-water interface allows for a rich exchange of minerals, leaching salts and potentially more complex organic molecules into the water, creating a chemical soup not unlike the environments around hydrothermal vents on Earth's ocean floor. These deep sea vents are thriving oases of life, ecosystems that operate entirely independently of sunlight, powered purely by chemical and geothermal energy. The conditions within Ganymede's dark, pressurized abyss could be strikingly similar, offering a stable, long-lived environment where life could potentially have arisen and persisted for billions of years. This transforms our largest moon from a frozen relic into a prime candidate in the search for life, a world with a hidden, watery heart that may hold secrets as profound as any in the cosmos. And yet, even the lopsided magnetosphere of Uranus seems orderly when compared to the sheer, unbridled chaos reigning on the solar system's true giant. At number 12, we are drawn into the swirling, tempestuous heart of Jupiter itself, a world that is less a planet and more a vast, living laboratory of atmospheric fury. The entire globe is a tapestry of storms, a constantly shifting canvas of cloud bands in shades of cream, ochre, and russet, all racing past each other at hundreds of miles per hour. But towering above all of this meteorological violence is one legendary, enduring tempest so vast it has been watched by astronomers for nearly 2 centuries and likely raged for centuries before that, the Great Red Spot. This is not merely a storm, it is a planetary institution, an anticyclonic maelstrom that could swallow our entire Earth whole with room to spare. For generations, we have wondered how such a colossal feature could persist for so long, resisting the turbulent forces that would tear lesser storms apart in a matter of days. The sheer scale of the Great Red Spot is almost impossible to comprehend. When it was first reliably observed in the 1830s, it was estimated to be over 40,000 kilometers across, wide enough to fit 3 Earths side by side. Although it has been steadily shrinking over the past century and is now a bit less than 16,000 kilometers in diameter, it is still larger than our entire planet. It is an anticyclone, meaning it rotates in a counterclockwise direction, completing one full revolution about every 6 Earth days. The winds at its outer edges scream at speeds exceeding 430 kilometers per hour, forces that would instantly shred any structure or form of life we can imagine. What we are seeing is essentially the top of a monstrous column of clouds that is thought to plunge hundreds of kilometers down into the planet's atmosphere. A storm that is not just a surface feature but a deep-rooted pillar of churning gas. The mystery of its longevity has puzzled scientists for generations. Storms on Earth are fueled by the energy of the sun heating the oceans and are quickly dissipated by friction with land masses. Jupiter, however, is a gas giant with no solid surface to disrupt its weather patterns. Its storms are powered from within by the immense heat left over from the planet's formation, slowly radiating outward from a searingly hot interior. This internal heat engine creates powerful convection currents, where warmer gas from deep within the planet rises, cools, and forms the bright ammonia ice clouds we see, while cooler gas sinks back down. The Great Red Spot acts like a massive atmospheric wheel, tapping into these vertical energy flows and the horizontal shear between the planet's fast-moving cloud bands. It is essentially a self-sustaining system, a stable vortex that consumes smaller storms and energy perturbations, using them to reinforce its own structure rather than being broken apart by them. It's a cosmic example of order emerging from chaos, a giant spinning eddy that has found a way to persist in the most turbulent environment imaginable. Our understanding of this behemoth and the countless other vortices that dot Jupiter's face has been utterly transformed by the Juno spacecraft. Since arriving at Jupiter in 2016, Juno's unprecedented polar orbits have given us our first clear views of the planet's poles, revealing a scene of breathtaking complexity that no one had predicted. Instead of the relatively orderly bands of the equatorial regions, the poles are a chaotic realm of gigantic, densely packed cyclones arranged in stunningly geometric patterns. At the North Pole, 8 massive cyclones swirl around a single central cyclone like petals on a monstrous flower. At the South Pole, 5 such storms are arranged in a pentagonal formation. Each of these polar cyclones is larger than the continental United States, and they are all locked in this stable, polygonal dance, jostling against one another but never merging. This discovery overturned all previous models of gas giant weather, proving that stable, organized storm structures can exist even in the planet's most turbulent regions, and raising new questions about the deep atmospheric dynamics that govern their formation and persistence. The visual data returned by Juno's JunoCam instrument is nothing short of art. We see close-up images of the Great Red Spot's intricate cloud tops, a tangle of swirling, crimson filaments, dark knots, and pale tendrils that reveal a structure of mind-boggling complexity. We can see the deep, darker reds at the storm's core, possibly indicating material being drawn up from deeper, warmer layers of the atmosphere, while the outer bands appear more filamentous and chaotic. Beyond the Great Red Spot, Juno has revealed a universe of other atmospheric wonders, brilliant white ovals that are themselves powerful anticyclones, chaotic and folded cloud regions nicknamed brown barges, and countless smaller vortices that dot the colorful belts and zones. These observations are helping scientists understand the third dimension of Jupiter's weather. By studying how these features move and interact, and by using microwave and gravity measurements to peer hundreds of kilometers beneath the visible cloud tops, researchers are beginning to map the planet's deep weather layer. They are discovering that these storms are not just skin deep. They have roots that may extend 60 miles or more into the planet's interior, tapping into vast, hidden reservoirs of heat and circulation. The Great Red Spot, therefore, is not just a singular wonder. It is the most prominent example of a fundamental and still deeply mysterious aspect of gas giant planets. It shows us that in the absence of a solid surface, the atmosphere itself can become a stage for permanent, planet-defining features, colossal engines of wind and cloud that can outlive civilizations and challenge our understanding of physics itself. But for a discovery that truly redefined our understanding of a distant world, we must travel to the very edge of the planetary frontier. At number 11, we uncover the organic haze of Pluto. For decades, this tiny world was little more than a blurry dot in our most powerful telescopes, a frozen mystery at the solar system's outer limits. All of that changed in July 2015, when NASA, a New Horizons spacecraft, screamed past Pluto at over 30,000 miles per hour, completely rewriting the textbook on this dwarf planet in a single, breathtaking flyby. Among its most stunning revelations was the sight of Pluto backlit by the sun, revealing its thin atmosphere not as a clear void, but as a spectacular, multi-layered blue haze, a delicate shroud of dozens of distinct concentric layers stretching hundreds of kilometers into the sky. This intricate atmospheric structure was a complete shock. Pluto's atmosphere, primarily composed of nitrogen with traces of methane and carbon monoxide, is incredibly thin, with a surface pressure 100,000 times less than Earth. Scientists expected it to be more or less uniform. Instead, New Horizons found a beautifully complex system of haze layers, like the delicate rings of a celestial onion. The blue tint itself provides a crucial clue to its composition. Sunlight scattering off very fine, soot-like particles in the haze tends to scatter blue light more effectively, much like how Earth's sky appears blue. But on Pluto, these aren't just any particles, they are the building blocks of life's chemistry, forming through a process that begins high above the surface. The driver of this process is the weak but persistent ultraviolet light from the distant sun. This UV radiation breaks apart methane molecules high in Pluto's atmosphere. The resulting molecular fragments are highly reactive, and they quickly begin to link up with each other and with nitrogen, forming increasingly large and complex chains of carbon, hydrogen, and nitrogen. These molecules continue to grow and combine, eventually forming tiny, solid particles of a reddish, sooty substance known as tholins. This term describes a wide variety of complex organic molecules that are not one specific compound, but a whole family of them, created through this kind of ultraviolet and cosmic ray-driven chemistry. As these tholin particles form, they slowly begin to drift down through the thin atmosphere, creating the beautiful stratified haze layers we observe. Their descent is not a steady rain, but is likely influenced by gravity waves, gentle, global-scale pulsations in the atmosphere caused by winds flowing over Pluto's dramatic topography, like its massive nitrogen ice plains and towering water ice mountains, which organize the haze into those distinct stacked layers. The ultimate destination for this slow-motion snowfall of organic material is Pluto's surface, and this is where the discovery becomes truly profound. New Horizons color images revealed vast regions on Pluto, most notably the sprawling, heart-shaped Tombaugh Regio, painted in a distinctive reddish-brown hue. This coloration is not from the underlying ice. It is a coating of these very same tholins that have been settling out of the atmosphere for millions, perhaps billions of years. The dwarf planet is essentially being painted by its own atmospheric processes. We see this reddish gunk concentrated on the bright, icy plains of Sputnik Planitia and coloring the rugged, mountainous terrain surrounding it. It's a planet-wide patina of prebiotic goo. The existence of tholins on Pluto is a discovery of monumental importance for astrobiology. Tholins themselves are not life, they are a tarry, complex mixture of organic compounds. But they are precisely the kind of chemical precursors that are thought to have been necessary for the origin of life on the early Earth. They contain many of the molecular building blocks, such as amino acids and nucleotide bases, that eventually assembled into the first self-replicating molecules. On Earth, these compounds were likely formed in the atmosphere and oceans or delivered by comets and asteroids. On Pluto, we are witnessing this very same process happening right now. It is a natural, ongoing factory for prebiotic chemistry, operating in the deep freeze of the Kuiper Belt. This suggests that the fundamental chemical steps that can lead to life are not unique to warm, balmy worlds like the early Earth. They are a universal process capable of occurring in the most remote and frigid environments, wherever you have simple carbon-containing molecules like methane and a source of energy, even something as faint as the distant sun's ultraviolet light. Pluto, therefore, transforms from a simple icy dwarf into a cosmic laboratory, demonstrating that the raw ingredients for life can be synthesized and spread across the surface of a world billions of miles from the Sun, profoundly expanding our concept of where the chemistry of life can begin. Now, let's turn our attention from the painted plains of Pluto to a much closer and equally bizarre phenomenon in the realm of the ice giants. At number 10, we have the strange case of Neptune's incomplete rings, or more precisely, its ring arcs. When you picture planetary rings, you likely imagine the magnificent, continuous hoops of ice and dust that encircle Saturn. Neptune, however, decided to do things differently. Its outermost ring, named the Adam's Ring, is not a flawless circle but is instead broken into a series of distinct, bright clumps. These are the ring arcs, and for a long time, their very existence seemed to violate the fundamental laws of orbital motion. How could a collection of loose particles possibly remain huddled together in a tight cluster, defying the natural tendency to spread out evenly along their entire orbital path? The mystery began with stellar occultation observations from Earth in the 1980s. Astronomers watched as a star winked out and reappeared several times as it passed behind Neptune, suggesting there were dense, isolated segments of material in orbit rather than a full ring. This was stunningly confirmed when Voyager 2 flew past Neptune in 1989. Its cameras revealed at least 4 prominent arcs embedded within the Adam's Ring, clumps named Courage, Liberté, Égalité, and Fraternité. These weren't just minor variations in density, they were concentrated bundles of particles like beads on a string, stubbornly maintaining their configuration. The immediate puzzle was one of simple physics. Left to their own devices, these particles should experience collisions and gravitational tugs that would cause them to dissipate, smearing out into a uniform band within just a few years. The fact that the arcs were so sharp and persistent meant something was actively confining them, acting like a celestial shepherd to keep the cosmic flock from wandering off. The prime suspect in this gravitational herding operation is Neptune's small moon, Galatea. Orbiting just inside the Adam's Ring, Galatea is thought to be the shepherd keeping the arcs in line through a delicate and fascinating process known as a corrotation orbital resonance. This is a specific kind of gravitational dance where the orbital periods of the ring particles and the moon are synchronized in a particular ratio. In this case, for every 42 orbits that a ring particle completes around Neptune, the moon Galatea completes exactly 43. This precise rhythm creates a series of stable gravitational pockets, regions where particles are effectively trapped. As the ring particles orbit, they repeatedly receive a gentle gravitational nudge from Galatea at the same point in their path. These nudges don't kick the particles away. Instead, they act like a restoring force, preventing the particles from drifting out of their designated zone and keeping them corralled within the arcs. Visualizing this can be tricky, but imagine a child on a swing. If you give the swing a small push at precisely the right moment in its arc, you don't stop its motion, you reinforce it, keeping it swinging steadily. Galatia's gravity acts in a similar way, providing a periodic push that counteracts the natural spreading of the ring material. The gravitational influence of the Moon creates a set of stable locations, much like the gravitational wells created by Jupiter for the Trojan asteroids, where the ring particles are dynamically trapped. It's a beautiful and delicate balance, a cosmic game of push and pull that results in these strange, segmented rings. Without Galatia's shepherding influence, the elegant arcs of courage, liberté, égalité, and fraternité would simply vanish, their particles dispersing into a faint, forgettable ring. Their continued existence is a direct and observable testament to the power of orbital resonances to sculpt and shape the debris around a planet, creating patterns of order where we would otherwise expect to find only chaos. But the ever-shifting dust storms of Mars are just one example of the planet's capacity for dramatic change. To find the evidence for its most profound transformation, we need to look not at its weather, but at its very axis. At number 17, we investigate the wandering poles of Mars. We think of a planet's north and south poles as fixed, permanent places, defined by the axis around which the world spins. But on Mars, this has not always been the case. Compelling evidence suggests that the entire outer shell of the planet, its crust and mantle, has dramatically shifted over billions of years, rolling over the core like the skin of a loose orange. This process, known as true polar wander, means that the geographic locations we now call the Martian North and South Poles were once in completely different places, a planetary reorientation that fundamentally reshaped the world's climate and geography. The driving force behind this incredible journey is a simple principle of physics. A spinning object, whether a child's top or an entire planet, is most stable when its mass is distributed evenly around its equator. Any significant, long-lived lump on the surface can throw this balance off, causing the entire outer layer of the planet to slowly, inexorably, shift until that heavy feature is relocated to the equator. On Mars, that colossal lump is the Tharsis Bulge, a volcanic province so immense it defies earthly comparison. This is home to the largest volcanoes in the entire solar system, including Olympus Mons, a shield volcano nearly 3 times the height of Mount Everest and covering an area roughly the size of the state of Arizona. The sheer mass of the Tharsis region, built up over billions of years by countless lava flows, is so staggering that it created a permanent planetary imbalance. To understand the scale, imagine spinning a basketball with a heavy lump of clay stuck to one side. The ball would wobble erratically until the clay eventually migrated to the equator, where the centrifugal force is strongest, stabilizing the spin. Scientists believe this is precisely what happened to Mars. As the Tharsis volcanic region grew heavier and heavier, the planet's crust and mantle slowly slid over its dense core, moving the enormous bulge toward the equatorial region where we find it today. This wasn't a fast, catastrophic event, but a gradual planetary scale creep that unfolded over perhaps billions of years. Sophisticated computer models, which map the gravitational and rotational dynamics of the ancient planet, show that before this shift began, the Tharsis Bulge was located at a much higher latitude. The reorientation was massive. Some models suggest the poles wandered by as much as 20 to 25 degrees, meaning the entire surface of the planet effectively moved hundreds of miles relative to its spin axis. The evidence for this ancient upheaval is written across the Martian landscape in features that no longer align with the planet's current climate. The most compelling clues are the remains of ancient glaciers and river valleys. Researchers have identified sedimentary deposits and glacial landforms in regions that are now tropical, located near the equator. These features could only have formed in a cold, polar environment. This creates a powerful paradox. How could glaciers form at the equator? The only logical explanation is that when those glaciers were active, those equatorial regions were not at the equator at all. They were located at one of the poles. As true polar wander occurred, these fossilized polar landscapes were transported to their current, warmer latitudes. Similarly, networks of valleys that appear to have been carved by flowing water now follow paths that seem climatically illogical. When you rewind the clock and account for the wandering poles, these ancient river systems suddenly align perfectly with what would have been the planet's past climatic belts, flowing from wet highlands to dry lowlands in a way that makes perfect sense for their original position. This grand reorientation did more than just move old glaciers around. It fundamentally altered the Martian climate itself. The movement of the Tharsis Bulge, which contains most of the planet's volcanic outgassing sites, would have drastically changed atmospheric circulation patterns. As the poles moved, the climate zones shifted with them. Regions that were once frigid and ice-covered warmed up, while areas that were once temperate plunged into a deep freeze. This could explain why evidence suggests that periods of warmer, wetter conditions on early Mars were not global, but were instead confined to specific regions that were, at that time, situated in more favorable climatic positions. The slow march of the poles essentially turned the planetary thermostat up in some places and down in others, leaving behind a complex and layered climatic history that we are only now beginning to decipher. The wandering poles of Mars reveal a world that is far more dynamic and historically complex than its barren, desert-like appearance suggests. A planet whose very face has been remapped by the titanic forces brewing in its interior. But for a volcano that truly defies our most basic assumptions, we must journey from the familiar realm of fire and rock to a world where geology takes on a frigid, alien form. At number 18, we explore the cryovolcanoes of Ceres. Nestled in the asteroid belt between Mars and Jupiter, Ceres is the largest object in that region, a 500-mile-wide dwarf planet that was, for a long time, written off as a primitive, inert protoplanet, a fossil from the solar system's dawn. When the Dawn spacecraft arrived in 2015, it revealed a world that was anything but dead. Its surface was surprisingly complex, dotted with bright, reflective spots, and most strikingly dominated by a single, colossal, and perplexing mountain, Ahuna Mons. This wasn't a mountain formed by the tectonic collisions that build ranges on Earth. It was a solitary peak rising 4 miles high from an otherwise flat plain, with incredibly steep, smooth sides and a distinct cracked summit. It looked utterly alone, a monumental pimple on the face of the dwarf planet, and its existence posed an immediate and profound mystery. The key to understanding Ahuna Mons lay in its unique shape and composition. Its flanks are scarred by long, vertical grooves and are strikingly smooth, devoid of the countless impact craters that cover the surrounding terrain. This indicated that its surface was remarkably young, geologically speaking. The mountain hadn't been sitting there for billions of years being pummeled by space debris. It was a recent feature. Furthermore, spectral data from Dawn's instruments revealed that the material on its slopes was not plain rock, but a mixture of water ice and various salts, including carbonates and chloride. This bizarre combination of a youthful age, a peculiar shape, and an icy, salty composition led scientists to a startling conclusion. Ahuna Mons is a cryovolcano. The term cryovolcano means cold volcano, and it represents a radical departure from the fiery eruptions we associate with volcanoes like those on Io or Earth. Instead of spewing molten rock, Ahuna Mons erupts a frigid, salty mud, a slurry of water ice, salts, and possibly other volatile compounds like ammonia. This briny mix, known as cryomagma, oozes out from the dwarf planet's interior and slowly piles up on the surface, freezing solid to form a massive mountainous dome. This discovery immediately raised a colossal question. What could possibly provide the energy to drive such dramatic geological activity on a small, isolated world in the asteroid belt? Ceres lacks a massive planet nearby, like Jupiter, to generate significant tidal heating. It is also too small to have retained much internal heat from its formation billions of years ago. The leading theory points to a surprising and elegant solution: antifreeze. Scientists believe that deep within Ceres lies a vast reservoir of brine, a global subsurface ocean, or at least large, isolated pockets of liquid water loaded with dissolved salts. These salts, much like the salt we spread on icy roads in winter, dramatically lower the freezing point of water, allowing it to remain in a liquid state even at the incredibly cold temperatures of the asteroid belt. This brine remains liquid, sloshing in a dark, subterranean reservoir, waiting for a release valve. The mechanism for an eruption is thought to be a beautiful, if slow, geological process. Over time, as this subsurface brine remains trapped, it can become buoyant relative to the surrounding rock and ice. Eventually, this buoyant, salty mud finds a weakness in the overlying crust, a crack or a fault line. It then begins its slow, relentless journey upward, intruding into the colder, solid outer layers of Ceres. As it rises and nears the frigid surface, it begins to freeze. But this freezing isn't instantaneous. The high salt content allows it to remain a viscous, slushy mixture for a long time, enabling it to push its way to the surface and extrude slowly, much like a thick, cold lava. It piles up layer by frozen layer, constructing the immense edifice of Ahuna Mons over millions of years. The presence of other, much more ancient and eroded cryovolcanic structures, identified through detailed topographic maps from dawn, suggests that this process has been intermittently active for a significant portion of Ceres' history, with Ahuna Mons simply being the youngest and most well-preserved example. The existence of a cryovolcano like Ahuna Mons transforms our understanding of Ceres from a simple rock into a dynamic ocean world. It provides compelling indirect evidence for that hidden, briny ocean, a place where liquid water has persisted for eons. This, in turn, catapults this dwarf planet into the conversation about potential habitability. Where there is liquid water, especially water in contact with a rocky mantle and enriched with complex chemistry from salts, the basic ingredients for life as we know it can assemble. While Ceres is a far cry from the warm, sunlit oceans of Earth, its dark, deep brine reservoirs could represent a new kind of niche, a cryohabitat where extremophile microorganisms, if they ever arose, could potentially persist. The solitary, icy mountain of Ahuna Mons is therefore much more than a geological oddity. It is a frozen sentinel, a testament to the unexpected geological vitality that can hide within even the smallest and seemingly most inert worlds, forcing us to reconsider where we might find the essential ingredients for life in our cosmic backyard. At number 19, we encounter a world that spins with such ferocious speed it has literally beaten itself into a new shape. This is Haumea, a dwarf planet out in the frigid Kuiper belt, and it holds the title of the fastest spinning large object in our entire solar system. Imagine a celestial body so determined to whirl that it completes a full rotation in less than 4 hours. To put that in perspective, a day on Haumea flashes by in the time it takes to watch a long movie, while here on Earth we're still patiently waiting for lunchtime. This dizzying velocity has profound consequences. The centrifugal force generated by the spin is so powerful that it has overcome Haumea's own gravity, stretching and pulling the world until it is no longer a sphere. Instead, Haumea is a distorted ellipsoid, a shape resembling a slightly flattened football or a river rock smoothed by a cosmic current. If you were to stand on its elongated surface, you would feel dramatically lighter at the points farthest from the core as the force of the spin actively tries to fling you off into space. This bizarre configuration immediately raises the question, what could have set this world spinning like a top struck by a giant? the most compelling explanation points to a cataclysmic event in the deep past, a colossal impact. Scientists theorize that billions of years ago, a massive object, perhaps another sizable dwarf planet, slammed directly into the proto-Haumea. This wasn't a glancing blow, it was a head-on collision of unimaginable force. The impact did more than just leave a scar. It transferred a monumental amount of angular momentum to Haumea, setting it spinning at its incredible, destabilizing rate. Think of it like striking a billiard ball off-center, causing it to spin rapidly as it travels. In Haumea's case, the blow was so violent that it fundamentally reshaped the entire world, and in the process gave birth to its entire family. The evidence for this ancient violence is written in the system of objects that now orbit the distorted dwarf planet. The colossal impact didn't just set Haumea spinning, it also blasted a tremendous amount of material off its surface, a plume of shattered ice and rock thrown out into space. From this ejected debris, Haumea's two small moons, Hiaka and Namaka, slowly coalesced. These moons now trace graceful, albeit complex, orbits around their rapidly spinning parent. But the most astonishing discovery came in 2017, when astronomers watching Haumea pass in front of a distant star made a completely unexpected observation. As the dwarf planet's elongated shape occulted the starlight, they detected a faint, additional dimming both before and after the main event. This revealed the presence of a thin, faint ring of material circling Haumea's equator. The existence of a ring around a small, distant object in the Kuiper belt was a stunning revelation. This ring is likely composed of the leftover debris from that ancient impact, particles that were neither reaccreted by Haumea nor able to clump together into a third moon. They now orbit in a stable, narrow band, a permanent, whispering echo of the violent crash that defined this world. What makes Haumea even more distinctive is its composition. Spectroscopic observations show its surface is covered in crystalline water ice, which is unusually bright and reflective. This presents another puzzle because in the cold depths of the Kuiper belt, amorphous ice is more common and stable. The presence of crystalline ice suggests that Haumea's surface was somehow heated and reformed in the relatively recent geological past. The very impact that spun it up provides a perfect explanation. The incredible energy released during the collision would have generated enough heat to melt vast quantities of surface ice. As this water rapidly refroze in the vacuum of space, it formed a fresh, bright, and crystalline coating, effectively giving the dwarf planet a gleaming new face. This combination of a rapid, shape-altering spin, a ring system, a family of moons, and a refreshed surface all point to a single, transformative catastrophe. Haumea stands as a cosmic monument to the role of chance and violence in shaping our solar system, a world forever frozen in the act of spinning out from a blow that nearly tore it apart, a dynamic and strangely beautiful reminder that even in the silent outer darkness, things are rarely ever at rest. Venturing now into a mystery that transcends the boundaries of our solar system and even our observable universe, we arrive at number 20, a cosmic conundrum known as dark flow. Just when we thought we had a handle on the large-scale structure and motion of the cosmos, astronomers stumbled upon something that shouldn't be happening, a coordinated movement on such a vast scale that it challenges our most fundamental models of the universe. This isn't about the expansion of the universe, which we understand is driven by dark energy, causing all galaxies to recede from one another. This is something else entirely, a peculiar, persistent stream where entire clusters of galaxies appear to be drifting in a specific, uniform direction, as if pulled by a cosmic tide whose source lies beyond the edge of everything we can see. The discovery of dark flow emerged from meticulous studies of the cosmic microwave background, or CMB, which is the remnant heat glow from the Big Bang itself. This radiation fills the entire universe and provides a snapshot of the infant cosmos. Crucially, it also serves as the ultimate frame of reference, a backdrop against which we can measure the motion of large structures. A team of scientists led by Alexander Kashlinsky analyzed data from NAS, a Wilkinson Microwave Anisotropy Probe, or WMAP, by studying the subtle distortions in the CMB caused by the movement of massive galaxy clusters through this radiation, an effect known as the kinematic Sunyaev-Zeldovich effect. What they found was staggering. They detected a coherent flow, a bulk motion, of thousands of galaxy clusters all moving at incredible speeds, millions of miles per hour toward a specific patch of sky between the constellations Centaurus and Vela. This motion was distinct from the universe's general expansion and could not be explained by the gravitational pull of any known supercluster or concentration of matter within the observable universe. It was as if a vast, unseen structure far beyond our cosmic horizon was exerting a gravitational tug on everything in our neighborhood. The implications of this are as profound as they are unsettling. The standard cosmological model, known as the lambda-CDM model, is built on the principle of isotropy and homogeneity, meaning the universe should look roughly the same in all directions and on very large scales. There should be no preferred direction. The gravitational forces that govern the motion of galaxies should all be local, arising from the distribution of visible matter and dark matter that we can map within our observable bubble. Dark flow blatantly contradicts this. It suggests that the mass distribution in the universe is not uniform on the largest scales, or that our observable universe is merely a small part of a much larger, grander structure whose gravitational influence is leaking into our own. One radical explanation posits that this flow could be evidence of a neighboring universe, a separate bubble of space-time born from the same inflationary epoch that created our own, but now residing in a multiverse beyond our view. The gravitational pull from such an external cosmos, unimaginably vast and dense, could be the invisible hand guiding this dark flow of galaxies. Naturally, a claim this extraordinary has been met with intense scrutiny and debate within the scientific community. Some researchers have questioned the statistical significance of the initial findings or suggested that alternative data analysis methods could eliminate the signal. However, follow-up studies using data from the more advanced Planck satellite have continued to show evidence of this anomalous flow, even if its exact characteristics and statistical strength are still a topic of active research. The very fact that this phenomenon persists in multiple datasets forces cosmologists to confront a deeply puzzling possibility. If dark flow is real, it means our cosmic map is profoundly incomplete. We are like sailors on a vast ocean, suddenly noticing that all the currents are flowing in one direction, hinting at a colossal, unseen continent just beyond the horizon. This isn't just a puzzle about galaxy clusters. It's a potential window into the truly infinite, a tantalizing clue that the greatest structures and forces in existence may lie forever outside our field of view, their presence inferred only by the mysterious, synchronized drift of the cosmic giants we can see. But if you think the Kuiper Belt is the final frontier of our solar system, think again. Far beyond the orbit of Neptune and the scattered disk lies the most distant and mysterious realm of all, a place so vast and faint that it exists more as a theoretical concept than an observed reality. At number 9, we enter the shadowy domain of the Oort cloud. Imagine a colossal, spherical shell of icy objects enveloping our entire solar system, a cosmic vault so distant that its inner edge is roughly 2,000 times farther from the Sun than Pluto, and its outer boundary may extend as far as a quarter of the way to the nearest star. This isn't a tightly packed belt, it's an incredibly sparse and diffuse halo of frozen relics, a ghostly remnant from the very dawn of our planetary system. The existence of the Oort cloud was first postulated by the Dutch astronomer Jan Oort in 1950, not because we could see it, but because we needed it to explain a specific type of comet. Astronomers realized that comets fall into two main categories: short-period comets, which orbit the Sun in less than 200 years and originate from the Kuiper Belt, and long-period comets which take thousands or even millions of years to complete a single, incredibly elongated orbit. These long-period comets appear to come from random directions in the sky, not from a flattened disk. Oort brilliantly deduced that the only source for such comets must be a vast spherical reservoir surrounding the solar system. His hypothesis solved the puzzle. The gentle gravitational nudges from passing stars and the tidal forces of the Milky Way galaxy itself can occasionally disturb these distant icy bodies, sending them plunging inward on long, elliptical journeys to become the spectacular comets we see in our inner solar system. The sheer scale of this hypothetical cloud is what truly bends the mind. While the inner, denser part, sometimes called the Hills cloud, might extend to about 20,000 astronomical units, the full Oort cloud could reach out to a staggering 100,000 astronomical units. To put that in perspective, 1 astronomical unit is the distance from Earth to the Sun. At such incredible distances, the Sun is barely more than a particularly bright star, its gravitational grip tenuous at best. The objects residing here are thought to be mostly icy planetesimals, the primordial building blocks of the outer planets that were violently scattered outward by the gravitational slingshots of Jupiter and Saturn during the solar system's chaotic infancy. They are cosmic fossils preserved in a deep freeze for 4.5 billion years, largely unchanged since their formation. This leads to one of the most bizarre and humbling possibilities about the Oort cloud. It may contain the majority of the mass of our entire solar system outside the Sun itself. While the 8 planets, asteroids, and Kuiper belt objects represent the consolidated, visible structure of our system, the Oort cloud is thought to be composed of trillions, perhaps even quadrillions, of individual icy bodies. Though each one is small, their collective number is so astronomically large that their total mass could easily outweigh everything else combined. Some estimates suggest it could hold several times the mass of Earth, all in the form of these scattered, frozen worldlets. This turns our conventional image of the solar system on its head. The bright, central part we all know is merely the tip of the iceberg, surrounded by an immense, invisible sphere of frozen material that represents the true bulk of what our Sun gravitationally controls. Perhaps the most captivating theory about this distant realm is that it is not entirely made of original solar system material. When our Sun was born, it was not in isolation but within a dense cluster of thousands of other sibling stars, all forming from the same giant molecular cloud. In this crowded stellar nursery, the gravitational pull of our Sun's neighbors could have stolen icy objects from their own infant planetary systems and vice versa. This means the Oort cloud might be a cosmic museum, containing not just our own solar system's leftovers, but also interstellar interlopers, icy visitors that were captured from other stars in that long-dispersed birth cluster. These frozen time capsules could hold the chemical signatures of other stellar systems, making them among the most pristine and informatively diverse objects in existence. The Oort cloud, therefore, is far more than just a source of comets. It is the solar system's ultimate attic, a dark and silent frontier holding the frozen secrets of our origin, and just possibly a sample of our stellar siblings from a time before our Sun ever shone alone in the galaxy. Moving outward from the hypothetical vastness of the Oort cloud, we find ourselves in a more structured but no less mysterious region of frozen debris. At number 8 on our list, we encounter one of the most compelling and hotly debated modern astronomical puzzles, the strange orbital clustering in the Kuiper belt. The Kuiper belt itself, that donut-shaped ring of icy worlds beyond Neptune, was once thought to be a relatively serene and predictable place, with objects following orbits dictated primarily by the known giant planets. But as our telescopes grew more powerful and we began to catalogue hundreds of these distant bodies, a bizarre pattern emerged, one so statistically unlikely that it has forced astronomers to consider a truly radical explanation: the existence of a massive, unseen planet, a ghost giant haunting the outer darkness. The mystery centers on a specific group of extreme trans-Neptunian objects, or ETNO. These are Kuiper belt objects with highly elongated orbits that never bring them close to Neptune's gravitational influence. When astronomers Konstantin Batygin and Mike Brown at Caltech began plotting the orbits of these distant bodies, they noticed something extraordinary. The orbits weren't randomly oriented in space. Instead, their points of closest approach to the Sun, their perihelia, were mysteriously clustered together, bunched up in a specific region of the sky. Even more strikingly, the orbits themselves were all tilted in a similar way, leaning over at nearly identical angles. This would be like finding a dozen different clocks, all randomly started, that not only show the same time but also have their minute hands tilted at the exact same degree. The probability of this happening by pure chance, according to statistical analysis, is astronomically low, well below 1%. Something, it seemed, was herding these orbits, organizing them against the natural tendency toward random distribution. The most elegant and powerful explanation put forward is the Planet 9 hypothesis. Batygin and Brown proposed that the gravitational influence of a previously undetected planet with a mass roughly 5 to 10 times that of Earth could be responsible for this bizarre clustering. This hypothetical world would orbit far beyond the Kuiper belt on a tremendously long and elliptical path, taking perhaps 10,000 to 20,000 years to complete a single journey around the Sun. Its immense gravity, acting over millions of years, would act like a hidden conductor, orchestrating the motion of these smaller bodies. The mechanism is a gravitational resonance, but on a grand scale. As these ETNO go around the Sun, the hypothetical Planet 9's gravity gives them a consistent, gentle tug at the same point in their long orbits. Over countless cycles, these tugs add up, shepherding the orbits into the aligned and tilted configuration we observe today, while simultaneously yanking any objects that would disrupt the pattern into completely different orbits or flinging them out of the solar system entirely. It's a cosmic sorting mechanism, and the clustered objects we see are the ones that have survived in this stable gravitational niche. The search for this phantom planet is now one of the great detective stories in modern astronomy, and it is fraught with immense challenges. The primary difficulty is its incredible distance. If it exists, Planet 9 is likely hundreds of times farther from the Sun than Earth is at its most distant. At such a range, the Sun would appear as little more than a very bright star, providing almost no illumination. Any light reflecting off its surface would be trillions of times fainter than what reaches us from Jupiter or Saturn, pushing our most powerful telescopes to their absolute limits. Astronomers are not looking for a pinprick of light moving quickly across the sky. They are searching for an incredibly slow, faint crawler that might take years or even decades to move a noticeable distance against the backdrop of fixed stars. They are using some of the world's most advanced observatories, like the Subaru telescope in Hawaii, to methodically scan vast swaths of the predicted orbit, taking images months or years apart and looking for any tiny dot that has shifted its position. This search is complicated by the fact that we don't know exactly where to look. The orbital calculations give a probable orbital path, a great, sweeping ellipse in the sky, but they cannot pinpoint the planet's current location on that path. It's like being told a ship is sailing somewhere along a specific transoceanic route, but not knowing if it's just leaving port or is days away from landfall. Every new discovery of a clustered Kuiper belt object helps refine the model and narrow the search field, but the haystack is unimaginably large and the needle is exceptionally dim. Skeptics of the Planet 9 hypothesis have proposed alternative explanations, such as the collective gravitational pull of many smaller, unseen Kuiper belt objects, or perhaps the lingering gravitational influence of a massive object that passed through our solar system long ago and is now gone. However, these alternatives often struggle to explain the strength and specificity of the observed clustering as elegantly as the single, massive perturber of Planet 9. The intense, ongoing hunt for this world is a thrilling reminder that our solar system's map is not yet complete, and that discoveries of the largest magnitude may still be waiting in the frozen, silent dark, their presence felt only by the synchronized dance of the tiny worlds they command. Now, from the dark, speculative frontiers of our solar system, we turn our gaze back toward the brilliant, life-giving star at its very center, where a mystery of a completely different nature has baffled physicists for generations. At number 7 on our list, we confront the Sun's coronal heating problem. Here's the puzzle in its simplest terms. If you were to fly a spacecraft into the Sun, logic would dictate that things get hotter the closer you get to the nuclear furnace at its core. And for the most part, that's true. The Sun's visible surface, the photosphere, is a toasty 10,000 degrees Fahrenheit. But if you continue upward through the Sun's outer atmosphere, a wispy, shimmering halo called the corona, the temperature doesn't drop. It skyrockets. In this ethereal region of space, the temperature soars to a mind-numbing 1 to 3 million degrees Fahrenheit. This is the ultimate cosmic contradiction. The Sun's atmosphere is hundreds of times hotter than its surface. It's as if you walked away from a blazing fire and suddenly found yourself in an inferno that is infinitely more intense. This phenomenon becomes breathtakingly visible during a total solar eclipse, when the moon perfectly blocks the Sun's blinding disk. For those precious few minutes of totality, the hidden corona is revealed in all its glory, a pearly white, intricate crown of luminous plasma, with delicate, striated streamers and ethereal loops stretching millions of miles out into the blackness of space. This isn't just beautiful, it's the visual evidence of the Sun's deepest atmospheric secret. The plasma in the corona is so incredibly hot that it glows in extreme ultraviolet and X-ray light, a form of radiation that can only be produced by matter at multimillion degree temperatures. This superheated corona is also the source of the solar wind, a constant supersonic stream of charged particles that flows outward, influencing the entire solar system and bathing our own planet in a sea of energy. So, what could possibly be pumping such staggering amounts of energy into the Sun's outer atmosphere? The energy clearly isn't coming from below, as the cooler surface would act as a barrier. The answer appears to lie in the Sun's immensely powerful and tangled magnetic field. The Sun is not a solid ball, it's a seething, churning sphere of plasma, and different parts of its surface rotate at different speeds. This constant, turbulent motion twists and stretches the magnetic field lines that are anchored to the Sun's surface, much like twisting a rubber band builds up tension. These magnetic field lines are conduits for energy, and when they become too strained, they can snap and reconfigure in a violent process known as magnetic reconnection. Think of it like this. Imagine two immensely powerful, invisible rubber bands crossing over each other. As the Sun's rotation twists them, the tension builds until snap, they break, and then instantly reconnect in a new, lower energy configuration. The colossal amount of energy released in that instantaneous snap is hurled outward, accelerating the surrounding plasma to incredible speeds and heating it to those millions of degrees we observe in the corona. This process can happen on massive scales, powering the gigantic solar flares and coronal mass ejections that we see as dramatic solar storms. But these large, explosive events are too infrequent to account for the corona's steady, blistering heat. This is where a more subtle and persistent theory comes into play. Many scientists now believe the primary heating mechanism is a constant universe of tiny, invisible explosions called nanoflares. These are not the colossal flares we see through telescopes. A single nanoflare is 1 billion times less energetic, a miniature version of magnetic reconnection happening constantly and everywhere across the Sun's surface. Individually, they are too small for us to detect directly with current technology, but collectively, they could provide a continuous, ubiquitous drizzle of energy, like 1 trillion microscopic firecrackers going off every second, all working together to keep the corona perpetually at a roaring simmer. It's a beautiful and elegant idea. The Sun's magnificent million-degree crown is maintained not by one giant engine, but by an uncountable number of tiny, invisible sprites dancing across its magnetic landscape. Solving this mystery is crucial because the behavior of the corona directly impacts us here on Earth through space weather, affecting satellite operations, power grids, and even astronaut safety. Understanding how it heats up is the key to predicting its most violent and disruptive outbursts. From the Sun's superheated corona, we now cast our gaze outward, past the orbits of all the known planets and into the space between the stars, where a new category of cosmic traveler has only just been revealed. At number 6 on our list, we have the interstellar visitors Oumuamua and Borisov. For all of human history, every single object we have ever tracked through the heavens, every comet, every asteroid, every speck of dust originated within our own solar system. That fundamental reality changed forever in October 2017, when astronomers at the Pan-STARRS Observatory in Hawaii spotted a faint point of light moving at a speed so blistering it could not be bound by the Sun's gravity. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. This was not a local object on a long orbit. It was a tourist from another star, the first confirmed interstellar object ever detected passing through our cosmic neighborhood. The initial data was perplexing enough. Its trajectory was hyperbolic, meaning it was moving too fast to be captured by the Sun, ensuring it would enter, swing around our star, and then depart forever into the depths of interstellar space. But as telescopes around the world swiveled to observe it, the mystery only deepened. The first major puzzle was its light curve, the pattern of how its brightness changed over time. As Oumuamua rotated, its observed brightness varied dramatically by a factor of 10. This extreme variation pointed to one thing, an utterly bizarre shape. To account for such a huge swing in brightness, the object had to be highly elongated, perhaps 10 times as long as it was wide. Imagine a cigar or a flat pancake tumbling end over end through the void. We have no natural objects in our solar system with such an extreme proportions. Most asteroids and comets are far more rounded or lumpy. This alone made Oumuamua a geological oddball, a shape that challenged our understanding of how objects form and evolve. Then came the second and even more baffling clue. As astronomers meticulously tracked its path against the background stars, they noticed something strange. Its trajectory could not be perfectly explained by gravity alone. After it whipped around the Sun, it was speeding up slightly, as if an invisible hand were giving it a gentle push. This is known as non-gravitational acceleration, and while it's not uncommon for comets, the mechanism is usually straightforward. When a comet's ices warm up near the Sun, they vaporize and erupt from the surface, creating a visible coma and tail of gas and dust that acts like a natural rocket engine, nudging the comet along. The profound mystery of Oumuamua was that it showed no such activity. Despite intense scrutiny by some of the world's most powerful telescopes, including Hubble, no coma, no tail, and no gas emissions of any kind were detected. It was as dark and inert as a piece of stone, yet something was clearly pushing it. The scientific community scrambled for explanations, leading to a fascinating spectrum of hypotheses. One of the leading natural explanations suggests Oumuamua could be a fragment of a Pluto-like world from another planetary system. In this scenario, a distant dwarf planet was shattered by a colossal impact, and Oumuamua is a shard of solid nitrogen ice that was blasted into interstellar space. As it approached our Sun, the nitrogen ice would have sublimated directly from solid to gas, providing the thrust for the non-gravitational acceleration without producing the dusty, visible tail typical of water ice comets. This would also explain its unusual shape, as a geological fragment could have sheared into an elongated slab. Other researchers proposed it could be a cosmic dust bunny, a very porous, low-density aggregate of material that is so light that the pressure of sunlight itself, photons striking its surface, could be enough to provide the observed push. The most speculative and certainly most headline-grabbing hypothesis came from Harvard astronomer Avi Loeb, who posited that the object's properties might be consistent with a light sail, an artificial, wafer-thin structure built by an intelligent civilization for propulsion. While this is considered highly unlikely by most of the scientific community, the very fact that it was proposed at all underscores just how anomalous Oumuamua was. Its combination of characteristics, the strange shape, the lack of a visible coma, and the clear non-gravitational acceleration, created a perfect storm of mystery that forced scientists to think in entirely new ways about what might be drifting between the stars. Just 2 years later, in August 2019, the universe sent us a second interstellar visitor, and this one was far more familiar. Comet 2I/Borisov, discovered by amateur astronomer Gennady Borisov, looked and behaved exactly like a textbook comet. As it neared the Sun, it developed a brilliant, extensive coma and a long, flowing tail of gas and dust. Its composition, studied through spectroscopy, was found to be remarkably similar to comets from our own Oort cloud, rich in carbon monoxide and water ice. Borisov was a comforting data point, proving that the basic processes of planet formation which create icy comets are not unique to our solar system. It was a pristine sample from another star, demonstrating that the ingredients for planets, oceans, and perhaps even life are common throughout the galaxy. The stark contrast between our two interstellar guests is what makes their discovery so profound. Oumuamua was an enigmatic outlier, a strange-shaped, dark object that defied easy classification and continues to spark debate years after its departure. Borisov was a familiar face from an alien land, a reminder that while some interstellar travelers will be bizarre and challenging, others will be reassuringly ordinary. Together, they have flung open a new window on the cosmos. We now know that our solar system is not a closed ecosystem. It is constantly being visited by bits and pieces of other worlds, other stars, other planetary systems. Every such visitor is a free sample of the galaxy's diversity, a tiny messenger carrying secrets from so far away we can scarcely imagine the journey. Their detection marks the beginning of a new era in astronomy, one where we are no longer just studying the distant stars, but are now able to examine pieces of them as they pass through our own celestial backyard. Tucked away on the vast gray plains of the Moon, there are features that look less like natural geology and more like cosmic graffiti. At number 5 on our list, we have the lunar swirls, with the most famous example being the magnificent Rhener Gamma. From orbit, this formation is a stunning, bright, cerulean-tinged patch with a beautifully defined, swirling shape, reminiscent of a cream swirl in a dark cup of coffee or a phantom galaxy painted onto the lunar surface. For centuries, astronomers using telescopes from Earth saw these bright patches and assumed they were simply unusual crater ejecta or strange volcanic deposits. But when spacecraft finally mapped the Moon in detail, a deeper mystery emerged. These swirls are not associated with any impact crater or volcanic vent. They sit on the surface, brilliant and untouched, while the surrounding terrain has been steadily darkened by billions of years of exposure to space. The secret to their pristine appearance lies not in their composition, but in an invisible shield, a localized magnetic field. The lunar surface is constantly bombarded by the solar wind, a relentless stream of charged particles from the sun. This relentless barrage has a darkening effect on the lunar soil or regolith through a process called space weathering. Over time, tiny iron nanoparticles form in the soil from the intense particle bombardment, and these particles absorb light, giving the Moon its characteristic dull gray hue. The lunar swirls, however, are bright because they have been protected from this darkening process. Data from orbiters like NAS, a lunar prospector, and India's Chandrayaan-1 have confirmed that each of these bright swirls sits directly atop a powerful, localized magnetic field. These magnetic bubbles, known as magnetic anomalies, act as miniature shields, deflecting the solar wind particles away from the surface directly beneath them. It's as if these patches of the moon have their own personal umbrellas, held open against the cosmic rain, keeping the soil beneath them looking fresh and young. This creates a stark contrast. The protected, swirl-covered soil remains reflective and bright, while the unprotected soil around it slowly weathers into a darker tone. This explanation, however, solves one mystery only to create a far more profound one. We understand how the swirls stay bright, but we are utterly perplexed by why these magnetic fields are there in the first place. The Moon, as a whole, does not have a global magnetic field like Earth's. Its internal dynamo shut down billions of years ago. So, what is generating these intense, highly localized magnetic shields? The leading theory points to a violent ancient history, suggesting these magnetic fields are the frozen remnants of colossal asteroid impacts. The idea is that when a large object struck the Moon billions of years ago, the unimaginable heat and pressure of the collision created a superheated plasma cloud. Within this turbulent, electrically conductive soup, complex currents could have been generated, which in turn created a powerful magnetic field. As the plasma cooled and settled back onto the surface, the magnetic signature could have become locked into the newly formed rocks, creating a permanent, fossilized magnet in the lunar crust. In this scenario, the swirl pattern we see today might actually be a kind of magnetic fossil, a perfect impression of that long-vanished impact plasma cloud, its ghostly form still deflecting the solar wind eons after the impactor itself vanished into dust. Yet there is another, even more intriguing hypothesis that connects these magnetic ghosts to the Moon's own internal geology. Some scientists propose that beneath the swirls lie subsurface magmatic intrusions, specifically bodies of ilmenite-rich material. Ilmenite is an iron-titanium oxide mineral that is strongly magnetic. The theory suggests that as large magma bodies cooled deep beneath the surface billions of years ago, this ilmenite settled out and crystallized. As it cooled through its Curie temperature, the point at which a material can become permanently magnetized, it did so in the presence of the Moon's ancient, now extinct global magnetic field. This would have imprinted a powerful and stable magnetic signature onto these specific subsurface structures. The swirling patterns on the surface could then be the surface expression of these deeply buried, magnetized lava sheets, with their magnetic fields reaching up and creating the protective bubbles we detect today. The beautiful, swirling shape itself might be the result of the complex interaction between this rising magnetic field and the fine, electrically charged dust of the lunar surface, which gets sorted and arranged by the magnetic forces. The Riener Gamma swirl, therefore, is not just a pretty pattern. It could be a window into the Moon's fiery, magnetic youth, a surface trace of a hidden, geological treasure buried deep below. This makes these enigmatic features far more than a curiosity. They are a dynamic interface where the invisible forces of magnetism and the relentless weathering of space meet, creating one of the most visually striking and scientifically valuable puzzles in our entire solar system. And so our journey through the solar system's strangest secrets comes to a close. From the geometric perfection of Saturn's hexagon to the chaotic tumble of Hyperion, from the hidden, life-giving oceans of Europa and Enceladus to the volcanic inferno of Io, we have witnessed a reality far more wondrous than the simple model we learned in school. We have encountered worlds painted by their own atmospheric chemistry, like Pluto, and others shaped by cataclysmic impacts, like the rapidly spinning dwarf planet Haumea. We have seen magnetic fields that are lopsided, rings that are incomplete, and dust storms that can engulf an entire planet. We have even received visitors from other star systems, reminding us that our solar system is not an isolated island, but part of a vast and interconnected galactic community. Each of these 25 discoveries, in its own unique way, chips away at our assumptions and reveals a cosmos that is dynamic, unpredictable, and infinitely creative. These aren't just random quirks, they are fundamental clues in the greatest detective story of all, the story of how our cosmic neighborhood came to be and how it works. The bizarre magnetic field of Uranus forces us to reconsider what churns in the hearts of ice giants. The Cryovolcano Ahuna Mons on Ceres suggests that even the smallest worlds can harbor profound geological activity and perhaps even subsurface oceans. The unexplained orbital clustering in the distant Kuiper belt hints at the possible presence of a hidden giant, a planet 9 still waiting to be found. And the enduring mystery of the Sun's superheated corona pushes the very limits of our understanding of plasma physics and magnetism. Every anomaly is an invitation to explore further, to question deeper, and to build better tools to uncover the truth. Our solar system is not a static museum exhibit. It is a living, breathing, and ever-evolving system, a grand natural laboratory where the most fundamental processes of the universe are on constant display. This continuous process of discovery is a testament to human curiosity and ingenuity. Every one of these bizarre findings is the result of decades of work by thousands of scientists, engineers, and explorers who dared to look up and ask why. They built the spacecraft that journeyed for years to reach distant worlds, designed the telescopes that peer into the deepest corners of our system, and developed the theories that make sense of the seemingly impossible. And the journey is far from over. Right now, new missions are being planned to delve even deeper into these mysteries. The Europa Clipper will soon set sail for Jupiter's ocean moon, and the Dragonfly rotorcraft will eventually fly through the thick atmosphere of Titan. Each new mission promises to reveal wonders we cannot yet even imagine, likely adding new, even more baffling entries to a future list of cosmic oddities. The story of our solar system is still being written, and we are all privileged to be living in an age where the next great revelation could be just a single data transmission away. Now we turn the conversation over to you. With 25 bizarre discoveries laid out, which one captured your imagination the most? Was it the notion of a hidden ocean within Ganymede, holding more water than all of Earth's seas combined? Or did the impossible geometry of Saturn's hexagon leave you in awe? Perhaps the idea of a distant, unseen planet silently shepherding the outer solar system sparked your sense of wonder. Let us know in the comments below which discovery fascinated you the most and why. We read every single one and love hearing your thoughts. If you enjoyed this deep dive into the mysteries next door, be sure to subscribe and hit the notification bell so you don't miss our next adventure. We have countless